Let's see if we can figure out sines and cosines all the way around the unit circle for all the common angles in degrees and in radians. 30 degrees, again, will remind you is the same as pi over 6 radians. Pi over 6. So we'll try to reinforce that as much as possible. That's 30 degrees. Now, what about the sine and the cosine? If this is a unit circle, and we'll assume that it is, in the unit circle the radius is 1, so the hypotenuse here is 1. And if you recall from what we know about special triangles, the shortest side is usually 1, the longest side is 2, and by Pythagorean theorem the other side is square root of 3. If that's the case, we could convert the ratios of these sides so that this hypotenuse is 1, just like this guy. So I'm going to do that by going through and dividing all the sides by 2. That way 2 divided by 2 gets me 1. We'll divide this guy by 2, and we'll divide this guy by 2. So now what we have is, I'm just going to go ahead and scratch this off and call this 1 now, because it was 2 divided by 2. What this means is that when we have a 30, 60, 90 triangle, and the hypotenuse is 1, this side over here is going to be 1/2 in length. And this side over here is going to be square root of 3 over 2 in length. And what we remember from SOHCAHTOA is that if we want to know about the cosine of 30 degrees, we will look at the adjacent side over the hypotenuse. In other words, it'll be square root of 3 over 2 over 1, which is the same as square root of 3 over 2. So we can go ahead and we can say that the cosine of 30 degrees is going to be equal to square root of 3 over 2 just by looking at it on the unit circle. And the same for the sine. We can say that the sine of 30 degrees is going to be equal to the opposite side over the hypotenuse, 1/2 over 1. That's the same as just 1/2. So we can put this all together now. Let's go ahead and let's see if we can go around the unit circle and get a few more of these. So now we've moved up, the orange or the terminal side of our angle has moved up to 60 degrees. We went 30 degrees more, so we're now at 60. And so we've also gone up to, in radians, we've now gone up to pi over 3, 180 over 3, or another way to say it is 2 pi over 6, because 30 was pi over 6. Here's 1 pi over 6, 2 pi over 6, 3 pi over 6. Every 30 is something pi over 6. But if you don't mind for now, I'm just going to call this pi over 3. I'm going to reduce. And then the other thing is we're going to take a look at the sine and the cosine. Again, in a 30, 60, 90 triangle, we know that the longest side is 2 times the shortest side. By the way, this time the shortest side is down here because 30 is up there. Shortest side. The shortest side is 1. The longest side is 2 times that. By Pythagorean theorem, we could figure out the other side. The only problem is that our hypotenuse in a unit circle is 1. The length of the radius. So we got to make it so that this special triangle here has a hypotenuse of 1. So we got to fix the ratio of these sides. And the way that we do that is we go through and we divide everything by 2. So now this essentially becomes just 1. And then divide this by 2 and divide this by 2. And that means that the ratios of the three sides have stayed the same. We're essentially multiplying each side by 1/2. And when we do that, what we get is this. We get the length of this side of the triangle must be square root of 3 over 2, and the length of this side of the triangle must be 1/2. Now, you might notice that there's some similarities here to what we got with 30 degrees. With 30 degrees, the 1/2 was over here, and the square root of 3 over 2 was over there. And it makes sense because we're just looking at the other side of the triangle. Instead of having the 30 degrees over here, we now have it over here. And so we flip these two around. Now, the other thing I want to point out to you is this, is that when we look at this point on the unit circle, it has the coordinates that look like this. 1/2 comma square root of 3 over 2. I'm hopeful that you can follow me that if I go out from the origin by 1/2 and then I go up to the unit circle, that x-coordinate must also be 1/2. And if I go from the origin up to the unit circle, square root of 3 over 2, and I hit the unit circle, that y-coordinate must be square root of 3 over 2. Now, the idea here is this, is that we have an x and we have a y, and if we have any point on the unit circle, our x, on the unit circle, our x-coordinate is always the cosine of the angle of interest, whatever it is. Well, if you don't mind, I'm just going to call it theta. And then the y-coordinate on the unit circle will always be the sine of the angle of interest, in this case our 60 degrees, it will always be given by this. So in this case, cosine of 60 must be 1/2, and sine of 60 degrees must be square root of 3 over 2. We can verify this very easy on a calculator, and it's probably worth taking a moment to do this. Let's go ahead and let's try. Let's go ahead and try sine of 60, so here's 60. And we'll do sine, we get 0.866. And then we'll do square root of 3 over 2. So we do 3 square root divided by 2 equals 0.866, sure enough. Let's try it one more time. Let's do, we know 1/2 is 0.5, so let's go ahead and let's do cosine of 60 degrees. And we get, sure enough, 0.5. So by looking at points on the unit circle, we can figure out what the sine and the cosine are of the corresponding central angle. And we can also figure out what the sine and the cosine are of the radians as well. In this case, the cosine of pi over 3 must be 1/2. The sine of pi over 3 must be square root of 3 over 2. So just to be safe, let's try finding the cosine of pi over 3 and the sine of pi over 3. Again, my conjecture is that the cosine of pi over 3, the cosine of the angle, will be x. It should be 0.5. Let's give it a try. On my calculator, I have to switch from degrees to radians mode, and you probably do too. So I'm going to go to radians mode, and then I'm going to go ahead and I'm going to type pi divided by 3 equals, and I get a number. Then I'll go ahead and take the cosine of that number. When I do, sure enough, I get 0.5. And one more time, just to be safe, let's try the sine of pi over 3. We expect square root of 3 over 2. So I'm going to go ahead and cancel all this. We'll do pi divided by 3 equals, and then we'll try to do the sine. We get 0.866. Again, just to be safe, let's go ahead and try. Let's go 3 square root divided by 2 equals, sure enough, 0.866. So pi over 3 to many calculators can be treated just like 60, especially when we go ahead and try to take the cosine. The cosine of pi over 3 is the same as the cosine of 60. The sine of pi over 3 is the same as sine over 60. And one other thing that I'd like to remind you is this. The tangent of any angle is equal to the sine of the angle divided by the cosine of the angle. So when we go and walk our way around the unit circle finding sines and cosines, we can also find the tangent just by dividing the sine by the cosine. If we divide this y by this x, we will get the tangent for 60 degrees. Again, probably worth trying the experiment. Let's give it a shot. So I'm going to go ahead and go back to degrees mode, so we're working with 60. So we'll say 60, and we'll go ahead and try taking the tangent. And when we do, we get 1.73 blah blah blah. So what happens if I do square root of 3 over 2 divided by 1/2? Turns out that that is exactly the same as just, let's try. If we divide square root of 3 divided by 2, and we divide that by 1/2, it's like multiplying this times 2, so that's simply square root of 3. So what we want to see is the tangent of 60 equal to the square root of 3? And the answer is, yeah, 1.73. It sure is. So this is kind of cool. We get a lot of stuff out of the unit circle. Kind of neat. So if you don't mind, I'm getting a little lazy and a little impatient, and I want to go the rest of the way around the unit circle. We did 30 degrees here, 60 here, here's 90 degrees. 90 is really very straightforward to get the sine and the cosine. It's just x is 0 and y is 1. So the cosine of 90 is 0 and the sine of 90 must be 1. But let's go ahead and go more 30 degrees. So here's 120 degrees, here's 150, here's 180. But what I want to show you is something really kind of cool. This 1/2 and square root of 3 over 2 are symmetrical. This 60 degree mark is symmetrical with this guy right here. And since they are, we get exactly the same numbers, but with different signs. So here the x coordinate is going to be negative 1/2, and the y coordinate stays exactly the same. So if we wanted to find what the sine and the cosine were for this angle, and by the way, this angle happens to be 120 degrees. Remember, all the way from way back over there, that guy is 120 degrees. All you got to do is you just have to know, you just know this. If you know this starting guy right here, you just switch around the square root of 3 over 2 and 1/2 here, and here you just change the sign of the x. Down here, we just swap these two guys around. We still have a negative, but now it's negative square root of 3 over 2, comma, positive 1/2. And why is that? Because this guy right here is supposed to be exactly symmetrical with this guy right here. And this guy right here was at square root of 3 over 2 and up 1/2. So this, we go out square root of 3 over 2 and up 1/2. And we can do this again and again. So we end up getting down here, we get, this will now be negative 1/2. Oops, I'm sorry, we're going way out just like we did here. We're going way out here. So it'll be negative square root of 3 over 2, just like this guy. But since we're going down here, it's also going to be comma negative 1/2. So what we can say here is that for this angle, if we go down 30 degrees from 180, this is going to be 210 degrees. What we end up getting is the cosine of 210 will be negative square root of 3 over 2, and the sine of 210 will be negative 1/2. That's pretty dang cool. Let's keep going. This guy here, we just take these two and shift them around. So it'll be negative 1/2, comma, negative square root of 3 over 2, parentheses. And something that I want to point out to you that's kind of important is you'll notice that this length here is a lot longer. The square root of 3 over 2 is longer than the 1/2. Numerically, square root of 3 over 2 is larger than 1/2. It'd be worthwhile for you to try on a calculator what square root of 3 over 2 is. You'll see it is larger than 1/2. And that's the reason why I know that the x here is going to be 1/2, because we're only going out 1/2 instead of all the way out to square root of 3 over 2. And the square root of 3 over 2, this guy must be a longer way down than this guy was. This guy is go down 1/2. This guy's go down square root of 3 over 2. And then we keep going all the way around. Again, this guy just has, this guy has a positive x. So now we go 1/2 x, and it's positive, and we've gone down negative square root of 3 over 2. And this is the way that we go around the unit circle and figure out all the sines and the cosines every 30 degrees. We can do the same thing with 45 degree angles.